Okay, so for x greater than 0, a greater than 0, a not equal to 1, ya equals log x if and only if x equals a to the y. Logarithms are inverses of exponential. Logarithms are inverses of exponential. F of x equals log ax is considered a logarithmic function with base a. Alright. All good? Okay, yes. No, just wave your hand. Good enough. Alright, so okay. So this is what you're asking yourself. When they ask you to do log 2 of 32, you're asking yourself 2 to what power gives you 32? All right, and that would be 5. So the log 2 of 32 is 5. Same thing with the next one. The base is 3, so 3 to what power gives you 1, and that would be 0. The log of 1, no matter what the base is 0. All right, the other two are a little trickier because they're less than 1. Log 4 of 2, 4 to what power gives you 2? Well, the square root of 4 is what gives you 2. And from the glory days of algebra 2, the square root is the same thing as 1/2. So 4 to the 1/2 equals 2. So whenever the number is the square root of the base, your answer is 1/2. Do the log 10 of 0.01. 0.01 is 1 over 100. Well, 1 over 100 is 1 over 10 squared. Using negative exponents, that is equivalent to 10 to the negative 2. So the log 10 of 0.01 is negative 2. Generally, when the number is smaller than the base, all right, generally when the number is smaller than the base but greater than 1, you're going to have a fraction or decimal. When the number is smaller than the base and less than 1, you're going to get a negative number. All right, so those would be the ones expected to do without a calculator at some point in your life. Now, the next thing is the common logarithm. All right. The common logarithm function is considered the logarithmic function with base 10. It can be evaluated on the graphing calculator or any calculator using the log button. This is the only base we usually use the calculator to find. So when it says log 10 or just log, we assume it's the base 10. All right. So when we're doing it, we hit the log button on your calculator, whatever it is, hit the number, and boom, it'll crank it out for us. All right. So the common logarithm of 10 would be 1. If I do 1/3 log, and you just enter it as a division problem, 1 divided by 3. You get negative 0.4771. When it doesn't tell you where to round to, you should go out to 4 decimal places. Log of a decimal, same idea, 0.3979. And finally, when you do the log of -2, it will give you an error message. Non-real answer. The log 10 of -2 does not exist. That is because 10 to the n is -2 is what we would be asking ourselves. Since 10 is positive, we cannot raise it to a net exponent. That gives us a negative. All right, other characteristics which are more important for later in the week. Log a of 1 is always 0 because a to the 0 is 1. Log a of a is 1 because a to the 1 is a. Log a of a to the x equals x, and a to the log a x equals x. They cancel each other out. We'll deal with that when we deal with the equation. And if the log a of x equals the log a of y, where a is the same number, then a is equal to y. All right. Perfect. All right, some graphing, and that's what the rest of our assignment will deal with today. We will utilize the concept of inverse functions and the fact logarithmic functions are inverses of exponential functions in order to graph. Create points of the corresponding exponential function. Flip the x and the y. Make sure to utilize the negative exponent. Hence, the -1, 0, and 1 we dealt with last week when we did exponential. Good. All right, so we'll start with the basic one. F of x equals log 5 of x. Okay? Now, if we started with y equals 5 to the x, which is the inverse of it, -1, 0, and 1 would result in 1/5, 1, and 5. That's from last week. All right? When you do the log of base n, all you're doing is flipping that. And it's the inverses of each other, so we flip the x's and the y. So 1/5 would give us -1. The log 5 of 1 would give us 0. The log 5 of 5 would give us 1. 1/5 -1 is about there. 1, 0 is about there. 5, 1 is a little up there. Okay? When you graph it, that is the general shape of a logarithmic graph. It is still increasing, but once you get into the positive numbers, it is increasing ever so slowly. Instead of a horizontal asymptote, there's a vertical asymptote. In this one, it's at x equals 0. When there's no number being added or subtracted, that is the asymptote. All right? So as a result, the domain is no longer all real numbers. The domain is greater than 0. The range now for logarithms is all real numbers. The asymptote is a vertical line instead of a horizontal line. And you will notice, just like exponentials, they're basically the same thing, except an inequality is replaced with an equation. Instead of the y-intercept, I would ask you for the x-intercept. All right? In this case, it's given to us as 1, 0. Ladies and gentlemen, if it's not in your table of values, you don't have to get it. All right? You don't have to get it. And finally, as x approaches infinity, f of x increases. Ever so slowly. All right. So those of you at home, I just posted what we're doing now. All right, in Google Classroom, if you want to print that out. All right. So what I would like you guys to do. All right, if you don't have it yet, it's okay. You can do it on a scratch piece of paper. Just graph f of x equals log 8 of x. So just graph the first one. F of x equals log 8 of x. mid is the asymptote. You got to cross that out. That's the x equals 0. All right, so the axis of symmetry is a misprint. It should be asymptote. All right, the domain, x is greater than 0, the range, all real numbers. The y-intercept, we're going to flip the x-intercept. All right, and that's going to be 1, 0. The asymptote is at x equals 0, and it's going to increase. The values you should pick are 1/8, -1, 0, oops, so we're flipping them, -1, 0, and 1. All right, -1 would be 1/8, 0 would be 1, 1 would be 8. So we flip those, 1/8, -1, 1, 0, 8, 1. All right, this, when there's nothing else being added or subtracted, just so you know, this is 1 over the base, that's 1, and that's the base. And then that's the -1, 0, 1. So the 1/8, -1, just like the last one we did. All right, 1, 0, and then 8, 1. There, and it gives us that. All right, that's the general shape of a logarithmic graph. Now the rest of these are all based upon the log 8 of x. We're just going to show you what happens each time. So, if I look at number 2, the log 8 of x plus 5. When there's a number being added on the outside that has no impact on the x whatsoever. All right, it has no impact on the x whatsoever. All right. All right. So the 1/8 and 1 and 8 are going to stay. The difference is, like when I plug in the 1/8, that's the -1. The -1 plus 5 is 4. When I plug in the 1, that becomes 0. 0 plus 5 is 5. When that becomes 8, that becomes 1. 1 plus 5 is 6. So the number being outside is a vertical shift. It affects your y. The net result is 1/8, 4, 1, 5, 8, 6. And then you can see the difference in your two graphs. That's the mother function, log 8 of x. That is the log 8 of x plus 5. It's been moved up. The asymptote is still at x equals 0. Because it is not a part of your table of values, when that occurs, don't worry about getting the x-intercept. All right? So when there's a number being added outside, it's not going to affect your x's whatsoever. So that's the net result on the graph. Good. All right, the next one involves two things. Number one, a negative on the outside, and number two, now the plus 5 is inside parentheses. Whenever you have parentheses, it changes your domain. All right, whenever you have parentheses, it changes your domain. All right, when there's no multiplier, when there's no coefficient, you just do the opposite of whatever the number is to your 1 over the base, 1 in the base. So in other words, the opposite of plus 5 is minus 5. So I'm just going to take each of those x's and minus 5. 8 minus 5 is 3. 1 minus 5 is -4. 1/8 minus 5 is -4 7/8. All right. Since there's no number being added outside, it goes back to 1, 0, and -1. Okay? You will then notice that instead of increasing, it's decreasing. That's because there's a negative outside. So for example, if I plugged in 3, 3 plus 5 is 8. The log of 8 is 1, but the negative turns into negative 1. When I plug in negative 4 plus 5 is 0. The negative of 0 has no impact. It's still 0. And then finally, 1/8 minus 5 is negative 4 7/8. So whenever there's no coefficient, like it is in this one, you just do the opposite of the number to your original table value. If you plot then, negative 4 7/8 is 1. Negative 4 is 0, 3, negative 1. Instead of going up, it's going down. That's because just like with exponentials, the negative is a reflection over the x-axis. All right? Whatever the number is out here, the opposite of that becomes your asymptote. The opposite of plus 5 is negative 5, so x equals negative 5 is your asymptote. If you look at all your points, they're all to the right of that. So my domain is x is greater than negative 5. Range is still all real numbers. And if you look at them, they're going down, so you know your function is equal. Good. All right, the back, log 8 of negative x. Log 8 of negative x. All right? Well, the idea is this. Whenever you now have a coefficient, and technically you do, negative 1, either in your head on paper, you set whatever's inside, and we'll do more of this in a second, equal to the 1/8, 1 1/8. So I said negative x equal to 1/8. Negative x equal to 1, negative x equal to 8. I'm sure some of you can do it in your head, that's fine. The net result, of course, is dividing by a negative. When I divide by a negative, my sign flips. So the 1/8 goes to negative 1/8. The 1 goes to negative 1. The 8 goes to negative 8. Thus, when I plug it back in, the negative of negative 8 is 8. The negative of negative 1 is 1. The negative of negative 1/8 is 1/8. It brings you back to negative 1 0 1. If you just try to plug in the values and get a log, it'll give you an error message. Can't do it. All right. So I got 1/8, negative 1, negative 1 0, negative 8 1. I plot them. That's what my graph looks like. All right. All right. Now my numbers are all to the left of the asymptote. So instead of greater than, it's now less than 0. Range is all real numbers. The x-intercept is one of my points, so I can slide that over, negative 1 0. There's no number being added outside parentheses, so x equals 0 is my axis of symmetry. And again, once you graph it, you recognize they're going down. And when they're going down, it is decreasing. All right. Log 8 of 2x minus 1 is f of x equals to log 8 of 2x minus 1. Again, this is the idea. All right. You take whatever's inside parentheses and you set it over equal to 1 over the base, 1 and the base. In this case, 1/8, 1/8. The other new thing is to get the domain and the asymptote, you set it equal to 0. All right? When I said 2x minus 1 equal to 1/8, I add the 1 to get 9/8, I divide by 2, makes my first x 9/16. When I said 2x minus 1 equal to 1, I add 1, 2, divide by 2, brings me back to 1. That doesn't happen very frequently. And then when I said 2x minus 1 equal to 8, add 1, you get 9, divide by 2, you get 9 over 2. Feel free to leave it as an improper fraction, that's fine. When we plug them in, 9/16, this becomes negative 1/8. That gives me the negative 1. When I plug in 1, this gives me 1, brings me to 0. 9/2 makes this 9. 9 minus 1 is 8. The log 8 of 8 gives me the 1. All right? For the domain and the asymptote, you set it equal to 0. Add 1, divide by 2, x equals to 1/2 is your asymptote. If you look at your points, 9/16, 1, 9/2, they're all to the right of the graph that we'll show you in a moment. That's why the domain is greater than the 1/2. Range is all real numbers. X-intercept is in the table, so we use that, 1 over 0. All right, then we look at the graph. Looks like that. All right. So that tells me it's increasing. All right. And to finish up for the day, f of x equals 2 log 8 of x minus 1. Again, the 2's on the outside, so it's not going to affect the x's. The only thing that affects the x's is the negative 1. Because there is no coefficient, we can get away with just doing the opposite to the x's. The opposite of negative 1 is 1. So 1 and 1/8, 2 and 9. Just by adding 1 to the other number. After that, everything can come from plugging it in. 9/8 becomes 1/8. Log of 1/8 is negative 1. Negative 1 times 2 is negative 2. Plug in 2. 2 minus 1 is 1. Log 8 of 1 is 0. 2 times 0 stays at 0. Plug in the 9. 9 minus 1 is 8. Log 8 of 8 is 1. 2 times 1 is 2. Basically, it's just changing it from going up 1 to going up 2. That's what the number on the outside does. All right? The opposite of negative 1 is 1, so that becomes your asymptote, x equals 1. The domain, all my x values look to be bigger than 1, so x is greater than 1. Range, all real numbers. X-intercepts in my table values to 0. If you look at your graph, which will show you in a second, going up, so that would be increasing. So that's what the graph looks like. All right. All right. Tonight's homework 1 through 7 are quick. I don't even need to see any work. Just write down your answer. 8 through 15 are graphs. So you got 8 graphs to do for homework tonight at midnight. All right. With the exception of, close that up. Go back here. All right. With the exception of Matthew Kohler, if you are good